Alright guys, today we are moving forward and looking at the mid-segment triangle. And the mid-segment triangle is formed by these mid-segments, pretty much just connecting the midpoints of a triangle. And the two things you want to know is, say XY here is a mid-segment, it must be parallel to the side opposite of it. So YZ, for example, is also parallel to AB, or XZ to BC. So that's what this means, just that we can say XY must be parallel to AC, the side opposite of it. And also that segment is half the length. So the segment length of XY is 1/2 the segment length of AC across Y. So what we're going to do is pretty much prove that we have mid-segments. So we're going to have this triangle. We want to show that this mid-segment KL, that it is parallel to the opposite side and that it's half of its length. So to do that, we need to first find what point K and what point L actually are. K is the midpoint of GH. L is the midpoint of HJ, so we're going to use the midpoint formula. So for point K, the midpoint of GH, we're going to add up the x values of those two points, -7 and -5, divide by 2. Same for the y values, -2 plus 6, divide that by 2, which means the point K is going to be -6, 2. Same for point L here. I'm going to do with H and J this time now, though. -5 plus 1 over 2, and 6 plus 2 over 2, which should give me a -2, 4. So those are my two midpoints. So to show that they are parallel, I need to find the slope of each. So I'll start with the slope of KL, and then I'm going to do after that the slope of the big segment GJ. So first for KL, slope is rise over run, or y's minus the x's. So I'm going to subtract the y's, 4 minus 2, subtract the x's in the same order, -2 minus -6, gives me 2 over 4, which reduces to 1/2. I do the same for GJ, the slope for G and J here, subtract the y's, it'll be 2 minus -2 over 1 minus -7, so I should get 4 over 8, which is also 1/2. So they are parallel, just like we needed. Now, the last step is then to see the length of each. So we'll start with KL, finding the distance of KL. This is using the distance formula, where I subtract my x values and square them, subtract the y values and square them, and add them up. So subtracting the x values, -2 minus a -6 and square it, and then for the y, 4 minus 2 and square it. So this will become plus or positive. They'll give me square root of 16. Plus this will become 4, so the square root of 20. And if I want to simplify that, the way I simplify it is by doing, well, this is the same as saying square root of 4 times the square root of 5. Square root of 4 is just 2, so 2 times the square root of 5. Now, for GJ, we got to find that length as well. We're going to do the same thing. We're going to do the square root of, subtract my x's, so it'll be 1 minus -7 and square it. And then subtract the y's, 2 minus -2, and square it. So this will give you the square root of 64 plus 16, which means I'm going to get the square root of 80 here. And the same thing, how can I simplify this? Well, I will simplify this by saying square root of 10, square root of 8, and I can simplify that even further. I can make it so that this becomes square root of 4 and square root of 2, and this here will become square root of 2 and the square root of 5. So the 4 here becomes a 2. We know that, so that's taken care of. I now have two different square roots of 2 here. I'm running out of room. Those two square roots of 2 become their own just regular 2. And all that's left is the square root of 5. So that can simplify to 4 times the square root of 5. And as you can see, the one is twice as big as the other, so you've gotten your proof of the KL being half of GJ, just like that.